So the biggest question is that what is food microbiology really? Well, for your information, food microbiology itself is such a wide area, so it's commonly divided into several subset areas, which are food spoilage, food fermentation, food processing, foodborne pathogen detection and identification, as well as foodborne illness and disease. Listed here is actually are the description of what a typical food microbiologist do. They study the role of microorganisms in food and food environment. Why food environment is because any contamination in the food environment can be transferred into food. So that's why it's important to look at the food environment section. In general, food is not sterile because there are natural microbe population present in the food or at the surface of the food, such as this orange here. So if the condition is not controlled, those microbes can grow, and those microbes, we call it spoilage microorganism. So this orange here that has been contaminated with mold growth is unfit for consumption, and we have to throw that away, and then it will cause food waste and food loss. So it's a big responsibility for food microbiologists to find a way how to prevent, how to delay the spoilage microorganism growth so that they can extend the shelf life of the food. Even the food is already cooked, we have to know that not all bad microbes already killed. So that's why it's important that cooked food need to be maintained at a safe temperature range where it should be below 5 degrees Celsius and above 60 degrees Celsius, which basically means that cold food need to be maintained cold and hot food need to be maintained hot. We don't want it to be fall within 5 degrees Celsius to 60 degrees Celsius because that's where the temperature that is favorable for microbial growth. For food fermentation is actually a good type of food spoilage where we use microorganism to perform its microbial activity in that food to produce a certain flavor, to produce a certain texture that sometimes can give a health benefit to human. Some example of fermented food include cheeses, sauerkraut, soy sauce. For food processing, this is important to manufacture the food in a safe food environment. So in food processing, usually food microbiologists will make sure that the cooking, the roasting, the baking, or any preservation that they want to add to the food really effective in controlling the microbes that are desirable, or to kill, inactivate the microbes that are not desirable in that food. For any food manufacturers, they have to obtain a certain certification in order for them to legally produce the food. In general, food manufacturers need to obtain HACCP, GMP, and MISTI. So for HACCP, it's basically listed all the production steps that they will apply to the food, and they have to justify how all these steps is safe from microbial contamination. For some specific step like kill step of the microbe, they have to provide some sort of scientific evidence to make sure that okay, if you, for example, apply this temperature for a certain minutes, this is sure can cause maybe 7 log reduction of E. coli, and therefore this food are safe for consumption. For GMP, it's basically focused on the environment of the food processing plant. Make sure that the handlers wearing a certain appropriate measure, like this one is you see in the picture, they wear hairnet to make sure that any body human part cannot contaminate the food, like hair, nail. If they have like a beard, they also have to cover that. They have to make sure they wear shoes that is being sanitized before they walked in to the food plant. GMP also focus on the plant itself, whether they have a good sewage system, whether they have a good aeration system within the plant, just to make sure that the condition will not be favorable for microbial growth. For Musti, it's actually just specific for Malaysia, but whereas for HACCP and GMP is actually worldwide. So when we see that all these licenses have been granted to the manufacturers, basically just increase the consumer confidence to consume food that is being manufactured from that certain manufacturer. Another subset area of food microbiology which is really important and very dear to me is that foodborne illness and disease. Like I was working with Salmonella before, so that's actually one of foodborne pathogen. If compared to other countries like US or UK, I think Malaysia has some sort of surveillance system, but it's maybe not as robust as compared to developed countries. So in developed countries like US, they have like this website called CDC, where they will report the number of cases, the number of foodborne pathogen have been associated to certain food, and then they will announce a food recalls to make sure that not all buyers will be affected by this foodborne outbreak or foodborne illness. We know that the implication of consuming contaminated food can cause us food poisoning, like heartburn, nausea, stomach ache, fever, and some microbe actually can be very deadly, like Salmonella. It can cause death, especially for immunocompromised groups, which are elderly, young children, pregnant women, and also immunocompromised person like HIV patient or person that undergoing chemotherapy. So for healthy adults like us, at some point of our life, maybe we have experienced foodborne illness, but because we are healthy adult, so usually it's just mild illness, so it can recover like within a few days after you went to the toilet, so that's not as severe. But for those who are in risky groups, it can be really dangerous to them. Another important area is, of course, microbiologists have to know how foodborne pathogen can be detected and can be identified. And also, we will aim for fast detection, fast and accurate detection. What kind of media that they can use, what kind of test kit they can use to detect certain foodborne pathogen. So from time to time, as the technologies become better, as the demand from food industry changes, food microbiologists will be constantly improving the way foodborne pathogen will be detected and identified in food. Now that we can understand what is food microbiology and what are the subset area of research that food microbiologists usually focus on, we also want to understand that food microbiology is actually part of food science and technology area, which is a bigger, wider area of research. Food microbiology is interrelated with all aspects of food science and technology, and what are other all aspects? It is listed here. So, other than food microbiology, food science and technologies focus on nutrition and health, food sustainability and policy, like food security, how to make sure that maybe a certain nation have a ample supply of food, how they want to make their own food. Food microbiologists food scientists and technology also focus on formulation and characterization. quality control and assurance. For food technologies or food scientists, they can also focus on how to market and manage the food, especially in food business. Some can also focus on new product development, maybe using a new ingredient. Like right now, there are major emphasis on producing plant-based food products because it's perceived as healthier. They also can focus on food engineering and processing. So if you working on the food processing plant, maybe you are controlling like a giant spray drying or like a giant oven to manufacture a big amount of food. So we have to make sure that the system works well. So this is where food engineers or food processors can come into place. So basically my intention is that for these first two slides, just want to give you an overall understanding what is food microbiology and what food microbiologists do and how that fits into food science and food technology area.